Hello, dear students. Assalamu alaikum. I hope you people will be fine and enjoying a very sound health. Today, I'm going to design a half adder and half subtractor, and today I will perform their simulation on Multisim simulation tool. So, first of all, I'm going to explain how basically half adder and half subtractor works, and what are basically combination circuits, and how we can define. So I'm going to show basically tentative a draw with all of you so that I can start for my today's work. Okay. Okay, dear students, I hope you can see my screen now. So basically, as I have already explained that today I'm going to design two basically combination circuits. One of them is basically half adder and second is basically half subtractor. Half adder and half subtractor, or we can say that full adder and full subtractor, both are basically the types of the combination circuits, and the combination circuits are basically those kind of circuits whose output is purely dependent upon input, and they don't have any memory element and they never retain their previous output. Every next output is purely dependent upon on pair of given inputs. Whatever you will apply on your input, your combination circuit will process that information and it will provide on your output side. So in this stream, I'm going to explain as a lab practical work second. In previous video, I have already explained how we can design logical circuits in multisim simulation tool and what are their practical application in computer science and IT technology. So first of all, I'm going to focus on half adder. Uh, Basically, in our arithmetic logical units, our 80% operations are basically arithmetic operations like addition, subtraction, and multiplication. That's why we have to understand if we are going to add something, if we are going to subtract something, what kind of logical circuits or combination circuits will perform that operations. So for in that case, I'm going to talk about the half adder. Half adder, let me try to draw some diagram over here. When we talk about the half adder, first of all, I'm going to draw over here a block diagram so that I can show you basically what are the input parameters and what are the output functions for this half adder. So half adder is basically a kind of combination circuit that is used to add two binary bits. So it takes two inputs, like you can say that A, I'm going to say that A, and second one is basically what is basically B. And we need to find out that in order to add two bits A and B, what we have to design in this block diagram so that our information can be processed. So in case of addition, we know that basically there are two output functions. First output function is basically, you can say that sum. I'm going to draw the symbolic shape of sum. And second one is basically the carry. So whenever you are going to add two bits or three bits, you will always have two output functions named as sum, and second one is basically the carry. In case of subtractor, we will see that we have a borrow and we have a difference. So basically half adder is a kind of combination circuit that will take two inputs, two binary inputs, and they will do what they will perform addition process. But what kind of addition process will be completed by a certain logical circuit, we need to find out for this question mark. So I'm going to design first of all truth table, because first we have to identify the problem, second we have to define our input parameters and output parameters, and third step is that ultimately we have to design a truth table. So basically we have two inputs A and B. For that case, we have four combinations. Like you can see that I'm going to design third step, that is basically the truth table design. So we must have at least four columns, because two columns are for input. Okay. 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 So I'm going to mark over here. You can see that A. second is basically what B, and I'm going to write down here basically what sum, and over here is basically the output function is carry. So when we have two variables, we could have four combinations like 00, 11. So I'm going to write down here 0, 0, 1, and next 1. Next, in next case, we have to do what? We have to make 0, 1, 0, and basically what 1. Same case, if we have three inputs, we could have three columns, four number of zeros, four number of ones, second column, two number of zeros, two number of ones, and third one, 0, 1, 0, 1. So let's start that. When we see that, when we are going to add 0 into 0, what could have the output? We have sum 0 and carry basically what? 0. And next, when we are going to add 0 into 1, we could have 0 plus 1, 1, sum 1, and basically what carry is basically 0. And next, 1 plus 0 is basically sum 1, and what carry is basically 0. In the last step, we could have 1, 1. It's basically 1 plus 1 is basically 2, like 2, 1, 0. In that case, this 0 is basically sum, and this 1 is basically what carry. So I need to write what sum 0, and basically now carry is 1. So we have just designed the truth table. Next step is that we need to extract equations, logical equations. For that case, for SOP standard, sum of product standards, we have to mark our output column where we have output 1 like this, and like this. Okay, so I'm going to write down over here the sum equation. Sum is basically what? You can see that it's basically A complement with B, and next A and B complement. So I can write over here A complement dot with what? B, next plus, I'm going to write down the plus, next A dot with what? B complement. And we know that this is basically A complement dot B, or plus A dot B complement is a logical equation of exclusive OR gate. So I'm going to write down here A plus B with circled. So this is my equation of what? Sum. Okay. This is the equation of my equation sum. I'm writing 1 over here. Okay. Next step is that I need to find out the equation of carry. So you can see that in the carry column, we have only one output high. And for that case, we need to write down the combination of the inputs like A and B. So I'm writing over here carry is equal to what? A and with B. Okay, this is the equation number 2. So simply, this is the basically AND gate operation. So these are two equations for what? These are two equations for sum and carry for in case of half subtractor, half adder. Now, same way, I'm going to do what? I'm going to make another block diagram. Okay, you can see that I'm going to draw another block diagram for second half of my today's work, that is basically half subtractor. Once again, in case of half subtractor, we can say that half subtractor is a similar kind of combination circuit that is used to subtract two number of bits A and B. And when we talk about more than 2 bits, we can say that it will be full subtractor. And when we talk about addition of more than 2 bits, that will be full adder. So in that case, we need to find out what is basically in this question mark. In this case, the subtraction process, we could see that there are two functions. In subtraction process, we have two output function. First is basically the borrow. I'm writing over capital B. And second is basically the difference. This is little bit opposite to that of the sum and carry. So output function is basically the borrow and the difference. And half subtractor is kind of circuit that is used to subtract two number of inputs A and B. And in case of more than inputs, we could have full subtractor or parallel bit subtractor. Same way with parallel bit adder as well. So next is what we have to design truth table, because truth table is very important in that case to explore the logical expressions. Okay. So once again, we have 4 columns. Okay. So over here is basically the A input, and over here is basically the B input. And now we have what we have: borrow, and what we have difference. For in that case, BB, you can write down here B as a what is the input. I can write over here B input, and you can also write over here B as a output if you are going to uh, misplace both these variables B and B. So B input is basically the input and the B output is basically the output. So I can see that we have 2 variables A and B, and same way I can write 0. I can write 2 zeros and 2 basically ones, and similarly 0, 1, 0, and 1. Let's start the operation. You can see that when we are going to subtract 0 into 0, we will get what 0 and what 0. And now this is very important thing. You cannot subtract 0 from 1. In that case, please be noted that in that case, we need to take a borrow 1. Now, basically, before that, we have 0, and now we have borrow 1 is basically, now it is basically 2. Now we need to subtract this 1. Now 2 minus 1, we will get 1. So therefore, I'm going to write down over here basically what 1. And next 1 minus 0, we couldn't have any kind of borrow in that case. So the borrow will be 0, and the difference will be basically the 1. And last case 1 minus 1, we have 0 and 0. Now you can see that in borrow column we have 1, and in difference we have 2 pair of outputs. So I am going to write down over here the equation of basically difference. Okay, difference T, I'm going to write down over here. You can see that in D, E complement with dot with B, and next basically what A dot B complement. So you can see that we have what equation: A complement dot with the B, plus next we have A dot with B complement. Okay, this is the difference. And you can see that the difference equation is almost similar to the sum equation. So basically, you can see that the sum equation and the difference equation are the same. Therefore, I can write over here simply A with exclusive OR with what? B. Okay. Okay, B. Now this is the difference equation. But in case of the borrow, I'm going to write down here basically the borrow equation, B out. Okay. So B out is basically the equation. You can see that is basically A complement dot with B. A complement dot with B. So these are the 4 equations that we are basically going to plot in Multisim simulation tool. And we are going to verify that either this simulation tool will help us to design and verify our half adder and half subtractor. So you can see that the difference between 4th equation and the 2nd equation is that we don't have A complement. So in design, we could have A switch, and then we need to use both A and A complement as in form of the input. So now I'm going to design the 1st and 2nd equation for half adder in Multisim, and 3rd and 4th equation for half subtractor in Multisim simulation tool. So I'm going to switch my screen with my simulation tool. Okay. So, dear students, you can see that now my screen is visible to everyone. Now I need to draw, first of all, my first session, that is half adder. For that case, we need to understand that there was a two equation. First was the sum, that was the exclusive OR of A and B, and second was the basically the carry equation, that was basically A dot B. So let's start. Okay. For that case, we know that we need two switches and two voltage sources ground and the VDD. So I'm going to place down both the inputs. You can see that VDD. Okay. Next, I need a ground voltage because zero logic. Okay. Next, I need two switches. Okay, you can see that I need to have two switches SPDT. Okay. And most important thing that we need to flip these switches. Okay. I need two switches. That's why I'm going to copy it. Okay. Next, I need to make a variable like A and B. So that's why I'm going to label it. Okay, you can see that I'm going to label it with A input because we are using A, and we are using with what label B. Okay. So we have now both the inputs. Next step is what we need to connect with these inputs with our ground and high voltage. So I'm going to connect it. Okay. 5 volt is basically used to represent with one logic, and ground is basically used to represent zero logic. Next, I need to have two logic gates. First, basically what in case of the sum, I need exclusive OR gate, and in case of carry, I need AND gate. So I'm going to place what two logic gates. I need to go to transistor logic and 7/4 LS. So first of all, I need AND gate. Okay. Okay, you can see that now I have AND gate. I just need to place this AND gate. Okay, over here. And next step is that I need to have exclusive OR gate. Exclusive OR gate is basically available in the bottom of the portion of my this selection of this 7/4 LS family of logical gates. So next step is that I need to find exclusive OR gate. You can see that this is the exclusive OR gate. So I'm going to place it over here. Okay. So now I have just completed my collection of both logical gates. That is basically the AND gate, and that is basically what the exclusive OR gate. Next, I need to find two illumination bulbs or LEDs so that we can test our 0 1 0 1 combination. For that case, I need to go to indicators. Now you can see that I'm going to find two LEDs probes. Okay. That one is green, and now this is the one red. So we need two LED probes because we have two output functions. What the name of the functions are, output functions are sum and carry. So that's why I'm going to label it with what sum. Okay, I'm going to sum. And next one is basically what now I need to mark this label with carry so that they can resemble with our design carry. Okay. So now I need to connect these my inputs with my logic gates. Okay, you can see that. Okay, I just need to adjust my simulation design. Next, I need to make this input from over here and this over here. Now I'm going to connect my first logic circuit with first output and second logic gate with second output. Now my circuit has been completed. Now I need to do what I need to run my simulation, and step by step we need to verify what we are going to design. For simulation run, we need to click on this button. You can see that when we have 0 0, the sum is 0 and the carry is 0. Next step, you can see that when 1 plus 0, it means what sum is 1 and carry is basically 0. And next step, that when 1 plus 1 is basically 2, and we know that sum is 0 and the carry is basically what? 1. This is according to the truth table that we have just designed. And you can see that when 0 plus 1, it will appear at sum 1 and carry 0. It means that our this simulation design is completely verifying our theoretical concept and logical equations. I hope it is understandable to everyone. Now, next step, I need to design half subtractor. For that case, I'm just doing a simple modification in my this circuit so that I can explain from a basic modification, because we have seen that in case of when we talk about half subtractor, we have almost similar equations. In case of borrow, we have seen that the borrow is basically what? A complement with dot with B. It means we have to just make a complement input from over here. If we somehow apply a NOT gate over here, and the same circuit will be used from half subtractor. And in case of difference, we have seen that already, that we must have the equation A exclusive OR with B. So remember that this equation. So now I'm going to once again little bit do modification in my circuit. I just need to remove this wire, okay, because I must have over here basically a NOT gate. So I need to find NOT gate once again, place component, and I need to go to transistor logic and need to find the NOT gate. Okay. Okay, I think this is the NOT gate. Okay, I'm just going to place over this NOT gate over here. Okay, so now you can see that I have what a NOT gate, and I'm going to connect this NOT gate. I'm going to connect this NOT gate. Unfortunately, I just connected with this NOT gate with my this input. It means what? I now have A. Now this is what A complement, and this A complement is now being connected over here. So I just need to highlight what I'm going to do over here. This is basically over here is basically the A input, and after this connection over here, sorry, unfortunately, this is basically the A input. And after this NOT gate, now this input is basically the A complement. A complement, okay, and next is basically what over here B. Now this output is basically A complement dot with B, and this output is basically with what? A exclusive OR gate with B. So you can see that I just perform a basic operation and modification about over here. Let me try to erase this. Okay, and now I next. Okay. Okay, this is now what? A over here. Now this is with not with A complement. Now this output function is what? This is basically A complement with dot with B and A exclusive OR with B. Next, I just need to mark my output function according to my design. Now I'm going to make this function as a basically difference, DI difference, and this function, output function, as in case of what? Borrow. Okay, borrow. Okay, so you can see that now my design is according to my output equation difference and the borrow. Now we need to do what? We need to start our simulation work in order to verify our theoretical concept and truth table. Okay, next let's start. We need to run this simulation. Okay, you can see that when 0 is subtracted with 0, we couldn't have a difference, we couldn't have a borrow. You can see output 0, 0. There is no elimination in our output side. Next, when we have a 0 input and we are going to subtract it from B, you can see that both the inputs are high. It means what? We have borrow one and we have difference one. It is same exactly according to our truth table and theoretical concept. Next step, that when we have both inputs 1 and 1, you can see that 1 minus 1 is basically sum 0 and the borrow is 0. It means it is according to our theoretical concept and truth table design. So next step is that 1 minus 0 is basically, you can see that difference, and over here is we don't have any borrow. So 1 0, this is same as output of our truth table. I hope this session for half adder and half subtractor is very helpful for all of you. Thank you for listening me and supporting me.